Okay. With some trepidation, I have my background as Venus when I'm talking to the Mars Society, but I'll explain why that is in a bit. And I think I can probably share my screen here with the video, or not video, with my charts. What I'd like to do is talk very briefly about sort of a new part of the space program, which is philanthropic space opportunities, and particularly about what my organization, the Breakthrough Prize Foundation's Breakthrough Initiatives, is doing, because I think this is a new dimension that hopefully you'll find exciting. Just by background, particularly in the United States, and I might add that I'm speaking to you from the Grand Duchy of Luxembourg right now, so this is really a global effort. The astronomy, starting really very early on, even in the early 19th century, was funded mostly by private funding. The picture you see there is Lick Observatory. It was in current dollars well over $1 billion US, and it was the world's largest observatory, founded overlooking the San Francisco Bay Area in the 1870s. The other picture is Robert Goddard, who was initially privately funded for his rocket work, and very early on by people that wanted to see us go to the moon. So there's a long tradition of privately funded space efforts. Now, our particular effort was started in 2015. This is the announcement photo. We announced the program at the Royal Society in London on July 20th, the Apollo anniversary, 2015. The man you see on the stage is our principal sponsor. It's Yuri Milner, an investor from Silicon Valley. You also notice Stephen Hawking. Until he passed away a couple of years ago, he was our principal science advisor. Now, the initiatives are about the fundamental questions of life in the universe, and I'll briefly kind of go over the major initiatives we've got, and then talk a little bit about some of the future things that we're looking at. The first question is there life elsewhere in the universe? And particularly in other solar systems. So we began almost 5 years ago, Breakthrough Watch, which is a program to see if we can find a life-bearing planet orbiting one of the nearby stars, particularly focused on the Alpha Centauri system, which I'll talk to a little bit more about. For those of you that aren't familiar with the Alpha Centauri system, it's really, really close, only 300,000 times further away than Mars usually. There's 3 stars in the system. 2 of them are sort of sun-like, one a little bigger, one a little smaller than the sun. And then there's a small distant star, a red dwarf star, which is about 1/10 the mass of the sun, but maybe only 1/10,000th of the brightness, that orbits the other 2. So it's a kind of an interesting system. As far as we know, it's a little older than the sun, and so it's kind of an interesting star system. Now, we announced the program on April 12th, 2016, that we were going to try to send some probes there, and I'll talk a little bit more about that. That's called Breakthrough Starshot. But shortly after we announced it, we didn't know of anything in the system, and but we now know that the small star Proxima Centauri has 2 planets, one of which is an Earth-sized planet orbiting in, at least as physics is concerned, the habitable zone of Proxima Centauri. Now, we've completed last year a major effort to see if we could look at Alpha Centauri A or B. I won't say anything about the results other than just tell you this is a picture from the movie Avatar, and it postulates a giant planet orbiting Alpha Centauri A in the habitable zone. But stay tuned to this question. Now, our second major program is a very exciting one. This is a revitalization of the search for extraterrestrial intelligence, which has now been more or less renamed as technosignatures. We have time on most of the world's large radio telescopes and some of the world's large optical telescopes to look for a technosignature. These include the a good bit of time, about 20% of the time, on the Green Bank 100-meter radio telescope. We've just started observations on the newest telescope, eventually to be the largest, the first part of the square kilometer array in South Africa. We also have just begun observations on the Chinese 500-meter, currently the world's largest radio telescope in China, and we have programs in a number of other optical and radio telescopes. I'd say so far we haven't found any techno-signatures, but a very exciting program. Now, the one that I probably is my personal favorite is Breakthrough Starshot. And this is the idea that can we send here later this century a probe to the nearest star system, to the Alpha Centauri system, hopefully if we find interesting planets, which we already seem to have a few. And the idea is we'd like to get there in a reasonable amount of time, several decades. So if you do the sums, you'll find out we have to go about 20% the speed of light. We think that we can do that, and we've started a research program to develop a method that looks very promising. It's to send a Gram-class payload via a light sail that's pushed by a very, very large laser, and I mean large. It's a kilometer scale, 100 gigawatt plus laser that could send this small probe to 20% light speed, going very well, but just started. Now, just to show you that we're already making good progress, this is Professor Zach Manchester, who was formerly at Stanford. He's now at Carnegie Mellon. He developed these they're called sprites, little chipsats. Last year, about 120 of them were launched on a CubeSat, and a few years before a couple others. And this weighs about 10 grams. So we're seeing that this is the next revolution in small satellites. Now, I want to talk about a new privately funded effort that we're working with the Keck Foundation and others. Is if we could go a little faster than we can go today, we can send small satellites out to about 500 astronomical units. If you're spaced at the right location, you can actually use the sun as a gravitational lens to image even planetary surfaces around a star that might be hundreds of light years away. So we're just beginning to look at this program. Very exciting effort on a way to directly image some distant exoplanets. And the key to this is to use not lasers, but the sunlight. And we have to get into very close to the sun, about less than 1/10 of an astronomical unit. And you can pick up speeds that give us hundreds, perhaps well in excess of 100 kilometers a second. So we could go perhaps 50 astronomical units per year and get out to this 500 astronomical unit location. Another very exciting effort. Now, certainly it's important to mention private sector efforts in addition to our own. I note the Bereshit program that was privately funded in Israel that almost got to the lunar surface, again launched by SpaceX, as another example of privately funded philanthropic efforts. Of course, SpaceX, and I hope Elon Musk tells you a little bit about some of these, is talking about moon missions that would be privately funded to send private individuals to the moon. And of course, another very interesting thing, and it's both making money and privately funded, is Blue Origin's Blue Moon program, which was announced by Jeff Bezos a little over a year ago. So another very exciting effort. And of course, Mr. Bezos envisages large space colonies that are very exciting. As a kind of a new habitat for humans. This is an older idea that was popularized by Jerry O'Neill several decades ago. And of course, and I won't steal any of Elon's thunder because I'm sure he's got new things to show, that the Mars missions, which I'm really looking forward to tuning in as well. Although I have to say that, I looked at this picture of what Mars looks like, and this is NASA Ames Research Center a few months ago, and during the fires, so we don't need to go all the way to Mars to feel like you're on Mars. But let me talk about a couple other things that are privately funded. just announced, and we're working with this Limitless Space Institute, a privately funded effort based in Texas, led by former Johnson Space Center folks, that is looking at more exotic propulsion schemes. As I noted, the Breakthrough Initiatives are co-sponsoring some of these efforts. Those announcements were made just recently. I think there were about 12 first stage contracts to look at even more exotic efforts, including some that some physicists would say violate the laws of physics, but that again, the target is interstellar, in this case, human missions to these nearby stars. Now, I'd like to close with a few brief comments about Venus. And probably a lot of you have seen in the news some very, very exciting measurements that showed that in the atmosphere of Venus is a gas, phosphine, which on Earth at least seems to always be associated with life. And of course, there are people that say, well, maybe there's other ways to make it. But as far as we know, this could be indication of life in the upper atmosphere of Venus. Probably a lot of you are aware that at about 50 kilometers in the atmosphere of Venus, sort of right in the middle of the cloud decks, is an area that the temperature and pressure are about what they are in the Earth's atmosphere. I might add, though, that it's not very Earth-like because there's very thick clouds of sulfuric acid, very pure sulfuric acid, which at least most life on Earth has problems with. I want to close with and this is there's an effort that Breakthrough Initiatives is now sponsored, led by Professor Sarah Seeger from MIT, one of the co-authors of the phosphine paper, to look at a privately funded mission that we could send maybe as early as 2023 to Venus to see if we could sample those levels of the atmosphere and potentially confirm at least the indications of life and maybe even life itself. I might add that we are working with Rocket Lab, which has developed a very low-cost mission that we think could send a probe there for a few tens of millions of dollars, and very exciting effort. But again, the message that we give is that Mars is very exciting, and we're certainly very interested in that. But a lot of the future, I think, is in the philanthropic space of high net worth people that want to do these things to advance science and humanity, and including that's sort of in addition to those interested in profit. Well, let me stop there, and there are some Q&A here. I'll be happy to answer those. But again, thank you a lot. This is a very exciting conference, and I remember the last few years I spoke at it, and unfortunately this year we're all in remotely, but hopefully to see all of you soon. Thanks.
Thank you, Doctor. First question: is asteroid mining something you will do, or is that too expensive because you have other areas of focus?
Well, that's interesting you ask, because where I'm sitting right now, I'm personally an advisor to the Grand Duchy of Luxembourg, which started a major space mining effort, very serious about it. Just a few weeks ago, they signed an agreement with NASA, the Artemis Accords, and that is one of the first partners looking at potentially mining resources on the moon, probably starting with water. So my foundation is not looking at it, but this is certainly something that I personally am very interested in, and my sponsors are happy to have me work with Luxembourg and a number of private companies.
All right. One of the attendees comments, "This is amazing. I can't believe we get to see this in our lifetimes. When do you think we will first send a probe to another star?"
Well, this is a good question. Our plans, and we think we're on track, would be the main challenge is building this immense laser beamer that would provide the power, and we think that we can do that on the order of maybe the James Webb Space Telescope, or at most the International Space Station cost. Probably we could start building it in the 2040s, and maybe in the 2050s, or perhaps sooner, begin sending these probes. So we think that, I don't know if it's in my lifetime, I'm 72 next week, or 71 next week, shouldn't make myself older than I am. I might make it. My dad lived to be almost 100, but I think most of the people listening should see it in their lifetime.
Okay, next question. Can we get more detail about the laser? How will it push the payload to Proxima Alpha Centauri?
Well, this is the key point of the research. The first thing we need to do is to get the price down of lasers. We can make lasers today that could do this. You need to get a very high quality beam of 100 to 200 gigawatts. That would today cost $1 trillion. So the first objective is, can we find laser technologies that could make this about 1,000 times cheaper? Already we're seeing, factors of 5 or 10 increase just since we started. So we think that will come along. The second challenge is, which we're addressing, is how do you build a light sail that can take 100 gigawatts of power without falling apart? We have an effort being led by Professor Harry Atwater at Caltech that's looking at that, and there looks to be pretty promising efforts. The third one is, how do you communicate back from Alpha Centauri? And we think we would use a very small laser on this sort of chipsat, this Graham-class spacecraft. We've just kicked off the effort. Professor Philip Mauskopf of Arizona State University is leading that effort for us, and that's where we've committed $100 million over the next 5 to 10 years to begin to develop that. But it looks very promising.
All right. Is there a higher chance of life on Venus or Mars?
Boy, this is a tough one to talk to the Mars Society. I'm pretty convinced that there's likely life underneath the surface of Mars in some of these aquifers that we're discovering. But the Venus thing is interesting. I would say that I would give a Mars chance of probably 2/3 of likely to find some extant life. I'd say Venus is about 1/3. Venus had oceans, we think, maybe longer than Mars did. We also know that material has been going back and forth between Mars, Venus, and Earth based on asteroid strikes. So if there was life on one of them, it very easily could come to the other. So I'm pretty optimistic, but I'd still bet slightly more on Mars.
Okay. Have Breakthrough Starshot researchers been funded? How can we track progress on Starshot? The website is not updated.
Thank you. I mean, that's a good question. We're somewhat remiss. We have funded so far there's about 24 programs, mostly in lasers and the light sail. We're beginning we have a request for proposals we're about to release for the communications effort. There'll be another dozen. I should make sure we update our website with what those teams are. But yes, they've been funded. The initial phase one is at the about the $100,000 to $200,000 level. We're just about to kick off phase two for the lasers, and that'll be at a few $1 million per effort. So the answer is yes. I am remiss in not making sure we updated our website. We'll do that soon.
Regarding public-private partnerships, how can these projects be scaled up to make them commercially viable? How long would it take to do this?
Well, this is happening today. I mean, of course, the best known public-private partnership is SpaceX, which has been very successful, funded jointly by government and private funding. There's many more that are, in fact, Rocket Lab itself was a public-private partnership involving both New Zealand, the United States, and private entities. The asteroid mining efforts that Luxembourg and the United States are doing are funded in part by NASA, in part by the Luxembourg Space Agency and private investment firms. So this is happening today, and it's quite exciting. Indeed, the Artemis Accords or the Artemis program and the Artemis Accords are explicitly mandating public-private international partnerships. So I think this is the wave of the future.
Next question. When do you think humanity will make it beyond the Kuiper Belt?
Wonderful question. I would say by the middle of the century.
How does a planet lose its atmosphere? Is it possible to recreate or force one once lost? How is it different than what we've done to Earth?
Well, I wish I knew how they gained and lost atmosphere. I mean, our own solar system is kind of mysterious. We say that, well, Mars lost an atmosphere, first of all, because it had less gravity and it doesn't have a large scale magnetic field. But Venus has a very thick atmosphere and very little magnetic field, almost none. So there's a lot of different things going on to cause a planet to lose its atmosphere or maybe gain a secondary one. Clearly, one of the most interesting things that have been talked about, mostly in science fiction, but in Mars a little bit more in fact, is can we restore an atmosphere to a planet like Mars, or can we take a planet like Venus and somehow precipitate out some of the atmosphere and make it habitable? And these are really interesting questions, and there's, of course, there's both practical questions and feasibility, but there's also ethical questions. Is that something that we should do or not if we could? And as mentioned, the ethical issues, the whole idea of humanity expanding in our solar system into other solar systems raises some significant philosophical and ethical questions. Our foundation was prepared to start or to have early this year an ethics conference at the University of Durham. We've had to postpone that, but we're going to consider the specific question about what's the ethics of spreading our life elsewhere, particularly if we find there is other life elsewhere. But that's I think, stay tuned to this spot.
If we were to somehow sublimate both polar ice caps on Mars, would we create an atmosphere? Would Mars then be more habitable?
Well, a lot of the analyses say yes, that if you can release some of the carbon dioxide that's tied up in the Martian poles, and indeed there's a lot of water underneath the surface. It appears that if you could melt all of the water on Mars, you'd have an ocean that would be hundreds of meters deep. Of course, the question is how we do that and do it in a manner that's cost effective and effective. But that's the whole terraforming of Mars thing, which I think is, at least in theory, there's been a lot written on it. It appears to be quite feasible to do that, and could restore an atmosphere that would probably be stable for many millions, maybe hundreds of millions of years.
Are any of these initiatives the result of the 100-year Starship project?
Well, that's a great question. I'd say that probably all of them are. For those of you who are not familiar with the 100-year Starship project, that was a program that I conspired with a senior person when I was at NASA Ames at DARPA, David Nyland, to say it's about time we start thinking about can we go, and if we send humans interstellar distances. We've both gotten a lot of trouble for it. We both had our jobs threatened. But on the other hand, it ignited a huge interest. We had almost 1,000 people at a conference in Florida, in Orlando. And my sponsor, Yuri Milner, when he said he was going to do the Starshot thing, first thing he said to me is, I want to help you do your 100-year Starship programs. So absolutely, I think sometimes a failed effort can ignite a lot of positive excitement. I think it has.
This questioner says, sorry, I'm breaking the laws of physics with this question. How optimistic are you that we can one day ramp up our ability to travel at the speed of light?
Well, of course, the physics we understand says you can never reach the speed of light, and certainly can't go faster. On the other hand, there are a number of very noted physicists that said it might be possible, and including Stephen Hawking, although he thought it was unlikely. To be safe, I'd say I think it's very unlikely that we'll be able to travel. We might eventually be able to travel a good percentage of light speed, but you should never say never. But there may be methods to get much closer to that speed, and there possibly are ways around it. People have thought about wormholes and so on. Indeed, that's one of the purposes of the Limitless Space Institute and their new programs. They are putting some effort into figuring out are there interesting real science approaches we can take that we can start funding.
Okay. Could the laser be used for anything else besides launching probes?
Great question. The thing that we've looked at that's quite interesting is that a laser this powerful could also be used to push an asteroid that was potentially hazardous and protect the Earth. It would be a different design. We would probably design our system that would only be able to push something to one star, probably Alpha Centauri. And but certainly the technology could be used for pushing asteroids. But even maybe more interesting is high-speed transit of probably not humans, but payload to Mars. And if you had a similar laser there pushing it back, so light propulsion in general, light sails is very promising. The idea of using lasers to artificially push them, I think, has enormous potential for moving things not only interstellar distances, but around our solar system.
All right. I'm afraid this is our last question for time's sake. Do you think we should be broadcasting signals into space to announce our presence to other potential intelligent life forms?
Boy, this is a question that gave me a lot of trouble no matter how I answer it, so I'm going to waffle a little bit. I'll tell you that Stephen Hawking, our science advisor, was very much opposed to this, and there was a series of books, the three-body problem, written in China the last few years that talked about the dangers of that. Conversely, there's other experts that are actually trying to think that it's very unlikely that there would be hostile aliens out there. I think it's probably the way I would answer this is that we should focus on finding evidence of alien intelligence before we talk about sending signals. And then after we find it, then it makes it a little easier to say, okay, how far away is this? What does it say? What does it mean? But I think this needs to be a global debate before we would do anything there. And I'm sort of, one day one way, one way the other. So I've waffled on that one. I usually don't waffle on questions, but that one I will.
Well, thank you, Doctor.
Well, thank you, and as Godspeed to all of you to Mars. I'm really looking forward to seeing humans on Mars very soon and settling the solar system and beyond.